Hi there. In this tutorial I'm going to demonstrate a few techniques to allow you to create something along these lines. So we've obviously got an ocean simulation here from a couple of different angles, and the most important thing is we've got an object, a bottle in this case, that appears to be floating in the ocean. This isn't hand animated as it were, this is genuinely the bottle is connected to the surface of what appears to be water. So I'm going to show you how to do that, and I'll also show you how to set up the ocean simulator to get a very quick and easy simulation of ocean waves. So to begin with, let's create the ocean itself. So I'm just going to add a simple cube. It doesn't really matter what you add because it's going to be changed by the modifier that we're going to apply. We'll come down to modifiers and we'll add the ocean modifier from the simulation section. And you can see immediately it sort of turns it into a plane. Now, when I did this, I used quite a high resolution in order to give a nice detailed surface to the water, but for this demonstration I'm only going to go with a resolution of 10 so that it all goes fairly quickly. Now to begin with, if I just press play, nothing seems to happen. And that's because we need to animate one of the parameters in here in order to get the water to move with time. And funnily enough, it's the time modifier. So I'm going to set my timeline first of all to about 600. So that's about 24 seconds at 25 frames a second. And I'm going to hold my pointer over the time and press I. So that's keyframed at the beginning of the animation, the time setting. And then I'm going to go to the end of my animation, which is at 600 frames. And I'm going to set this to about 35. You'll need to experiment with the value you use. To some extent it depends on the size of the water that you're trying to simulate, whether it's close in or far away and so on. But this seemed to be a value that worked for me. And then I'm going to keyframe it again. So if I go back to the beginning now and press play, you can see that it's moving. However, remember when you just initially keyframe something like that, it will use a non-linear interpolation. So by that I mean if I change this window to the graph editor, you can see this is the interpolation for the time, and you can see it starts slow, speeds up, and then slows down again. And that's not what we want. That's obviously typically not how the water is going to work. So we need to go to key and just say interpolation mode linear, and now you can see we've got a straight line there. So let's go back to 3D viewport and just press play again, and you can see we've now got something reasonably good going on. There's a few other settings we need to change. Now to make it a bigger area without having to simulate more, as it were, I added a repeat on the X and a repeat on the Y. And you can already see all it's doing effectively is duplicating this block over here and then duplicating the two of them over here. But obviously it's also setting it up such that this side joins to that side. So it doesn't add a huge amount more work for Blender to do in simulating it, but it does give you a much bigger area to play with. So there's beginnings of our animation. So I've made an ocean surface that's somewhat similar to the ocean surface I made before. So I'll just use the same sort of settings as I ended up with, and that's a good starting point. In fact, the default settings are not bad. So we've already talked about the repeats. Depth I left as it was. So obviously this affects the shape of the waves and things like that. As I said, resolution I ended up putting much higher. I used about 20, but that does take a lot longer for Blender to calculate, just to calculate the simulation. And obviously it provides a lot more polygons for Blender to render eventually as well. The size I set to 2. So you can see again that makes the blocks themselves bigger, but you'll also see the waves are more gentle now because they're spread over a larger area. Spatial size I put down then to 25, so that's probably just reversed what I just did, but nevertheless that's the settings I ended up with. Choppiness I increased to 1.5, just sort of increase the peaks of the wave slightly. Scale I also increased to 1.5. just to exaggerate the wave slightly. Smallest wave and wind velocity I left as they were. And alignment just allows you to change how the waves align relative to the wind. I did select generate normals and I selected generate foam. So when you bake, you can also bake in some data that can be used to indicate where foam on the surface of the waves might be, where the water has been foamed up by the wind, I guess. And you can also generate normals from that, which allows you to use a bump map to lift that foam above the surface of the water, for example. And then we need to give this data that we're creating a name, so I'll call that foam1. It tells you the path that it's storing it in there. So what I'll now do is bake it, and because I'm doing this at a relatively low resolution, it shouldn't take too long. And we can see the progress down here. it can take even hours once you set this up to a high resolution. So if we press play now, it's actually slightly slower, and this may slightly be a bug in Blender 2.8 beta. But obviously what it's doing is reading that from a file on the disk rather than running it from memory, and that's why it's slowed down somewhat. So I'm going to delete that bake at the moment just so we've got a faster simulation. And then we can move on. So now how do we get something to float on that surface? Well, let's just give the ocean a basic material. We'll give it a sort of greenish material, but most importantly, let's give it a dark greenish color in the viewport so we can see what we're doing. So now we're going to add a simple plane. Zoom in on that plane. I'd suggest making it slightly larger than the default, and it just needs to be slightly above the surface of the ocean. Go into edit mode, right click and subdivide. If you're using an earlier version of Blender, you can just press W to do that. And on the subdivide menu, just increase it a little. It doesn't need too many subdivisions, but a couple of subdivisions is worth doing. So now go to the object data with all the vertices selected and just press plus to add a new group and assign. We can check that by double pressing A to deselect and then just click select over here, and you can see they've all been selected. So now go to modifiers and add a modifier and add the shrink wrap modifier. Under the target, select, in this case, cube. I should probably have named that ocean. Should default to nearest surface point and on surface. And now if we press play, you can already see this plane is moving around. If you want it to stay above the surface, you can just click this offset up here. It doesn't matter too much, but don't put it too far above the surface. So you can see that plane is conforming to the surface of the ocean. Next, let's add an object. So let's make a basic bottle. I'm just going to move that part up a little bit. E to extrude, GZ, scale in. E to extrude again, GZ. I'm making a very basic bottle here, not worrying too much about detail. And then Control 2 to add a subdivision surface. And in object mode, right click and just say shade smooth. So it's a rough sort of bottle type shape, very rough. And we'll give that some sort of color. I'll make that bright blue. We'll call the material bottle, and we'll call the object bottle. And I call these planes that I use to control the objects, I'll call that float 1. So at this point, we need to go to object constraints with the bottle selected. We need to add a constraint, which is copy location. In here, we'll select float 1. So if I press play at this point, I haven't changed anything yet, nothing's happening. But if I go to vertex group and I select group, which is the vertex group that we created for float 1, now you can see the bottle is floating up and down with that plane. So already we started to get something that floats. What it's not doing is changing its angle. So what we can now do is add copy rotation. Again, select float 1 and again select group. You may just be able to see the bottle's got a little bit of wobble on it from the ocean. And if I select that plane and I move it around, depending on where it is, you can actually see we get a bit more from the bottle. I'm going to, I think, increase the size of the waves on this ocean just to give us a more of an extreme view. That's better. So you can now see as that bottle is floating up and down, although it's stationary in one XY position, it is going up and down, and also the angle is changing with it. So in terms of physical simulation, this is almost complete now. So let's just move this throughout the animation. So let's move the bottle over here, press I and record the location. Go to the end of the animation, move the bottle over here somewhere, press I and record the location. Again, not forgetting that we need to go to the graph editor and just change the key interpolation mode to linear, back to the 3D viewport, back to the beginning and press play, and we can see we've got our bottle making its way across the scene, and It's basically sticking to the surface of the ocean as it does so. Now obviously the bottle should float quite a bit lower than that, and in order to do that we need to go into edit mode, select all the vertices and then move the bottle down. Basically that little orange dot, which is the origin of our shape, is the important thing, and then perhaps give it some angle there. So now when I press play, our bottle's sitting at some angle and moving around as it floats along. If we select our float object, we can press M and we can create a new collection which we might call controls. Control. And I'm going to make that selection, for the moment, not visible at all and also not renderable. So now our bottle's floating along quite nicely in our ocean. So just very briefly now, how to make the ocean a little more convincing. First of all, we need to add some light into the scene. So let's say use nodes. I'm doing this for a cycles render. You could just as easily do this for Eevee, but obviously some of the lighting effects won't be as detailed. We'll click the little dot here next to color and we'll say sky texture. I'm just going to push that over there slightly, maybe not quite so far. And I'll also Shift A and just add a light, which is a sun light. We'll put that over here somewhere, scale it up so it's easy to see what I'm doing. And we'll leave it there for now. We'll go to the light controls, make it slightly yellow, make it a strength of 5, and we'll make it 0.01 for size. So if we go to rendered view now, that's obviously not a very realistic sea at the moment, and we'll start building up our sea. So I'm going to call up another window, and we'll make that the shader editor. Make sure the sea is selected. I just pressed N to remove that menu at the right hand side. And for the viewport, we'll just say 10 samples. With a render of 60. So here's our sea material, and to begin with I'm just going to go with a sort of lightish greenish bluish colour there. I'm now going to add a subsurface colour, which is also a greeny blue colour but is quite dark, slightly more bluish than that. I'm trying to simulate deep sea obviously, and I used a subsurface of 0.36. Now it's not going to look quite right yet, and I'll explain why as I go along. I'm also going to turn this off, which will turn off that grid, which you may be able to see. Coming down, I don't need to change these defaults. This is the principled BSDF shader, which is the default shader now. And I changed the index of refraction to 1.33, which is basically that of water. Transmission I'm going to play with by connecting to other nodes, but transmission roughness I set to about 0.1, and normal we'll be using shortly as well. So now coming up to here, I'm going to add another shader, which is a mix shader. We'll drop that there. And then I'm going to add an input, which is a layer weight. Now in theory you don't need this with the principled shader, but I found adding this, certainly for this scene, seemed to help. I'm going to take the Fresnel output from the layer weight and put that into the factor of the mix shader. I set the blend mode to about 0.1, and now I'm going to add another shader, which is the transparent shader, and just connect that to the other side. All this is doing really is that at certain angles you will appear to see through the surface of the water rather than see light reflecting off it. Now at the moment nothing's controlling the roughness, so it's got a rough surface. I'm going to be connecting something in there, but for the moment let's turn it down and make it quite a shiny surface. And you can see it's got a lot darker, but at the moment there's nothing beneath the sea, so we're actually seeing the sky through the sea. So before we go any further, let's come out of rendered mode, look from above, and we'll just add another mesh plane. Scale that up, and it needs to be bigger than the sea itself, really, depending on what angle you're looking at though. Put it about there, and bring it down. I then gave that a simple material. It doesn't need to have anything fancy about it, but it does need to be quite a dark colour, so I made it a very dark green, and we'll put that to the viewport colour as well. So all that really does is cut some of the light out that would otherwise be shining up through. So if we go back to rendered view now, so we've now got a slightly clearer difference between light that's reflecting off the surface and any light that might be transmitting through it. And I'll just turn transmission up a little bit there. Again, this is going to be a setting that we'll control. So we've got the beginnings of our surface, but obviously it doesn't look quite right yet. So now I'm going to come over to the left slightly, and I'm going to add an input, which is a texture coordinate node. Next, I'm going to add a noise texture, and I'm going to use the normal output of the texture coordinate node to set that. Basically sets how that maps to the surface. I used a scale of about 40, high level of detail, and 0.1 of distortion just a tiny bit of distortion which gives you sort of curls. I'll explain what we're doing with this noise in a moment. I'm now going to add a converter which is a color ramp. Take the factor output of that noise into one side of the color ramp and just move the left hand point up a little and the right hand point down a little. Again, you'll have to experiment to find what works for you. And I set the curve to cardinal. So this is just applying a kind of filter to that noise. Add an input which is an attribute. So I'm just going to stop that rendering for a moment. I'm going to go to my ocean simulator and I'm going to say bake. As you know, this will slow it down from a playback standpoint, but we've got the floating done now. But what it will do is it will generate this data. So in here, if you remember, we called our foam data layer foam 1. So let's put foam 1 in here. And now we're going to add a color mix node. We're going to set it to dodge. It's just a combination method. You can try different ones to see what you get. We're going to put the foam layer into one side and the noise into the other. So what this is doing, this is telling us where we're going to have our foam, and we'll then use that information. This section here is basically overlaying noise on top of that. So rather than just a straight layer of foam in one place, it's interrupted as if it's by bubbles. It makes it more noisy, which is what we want for foam. We then add another color ramp. I flipped the color ramp and then I set the white side down almost to 0 and then the dark side just above it. So this is just refining the filter. It's just filtering it down to give you definitely one or the other. And then take the color output and put that into there. You don't have to make such a complicated set of nodes. It just helps if you want the appearance to look like there's real foam. So now we're going to use that output in several places. So let's take another color mix node. This one will just set to mix, and we're going to control it with that color ramp. And that's going to switch between basically white on the one side if we want white foam, and some kind of sea-like color on the other. So that's deciding, is it foam or is it seawater? And that goes into our base color here. And we'll let that run now. Next I added a converter which is a math node. Put the output of the mix node into one side of that. Set it to 0.05. This is just to scale it really, and take that into the roughness. So this gives some variation in roughness. We want it to be more rough where there is foam basically, and this math node just allows us to scale it, and we just set that to multiply. Then I'm going to add a vector node which is a bump node. That connects to the normal input, and again I'm going to take the output from this mix node, and that's going to go into the height input on this bump node. I set the strength to about 0.025, and that's really just basically making the foam, whatever foam there is, appear slightly above the surface. Going back to this color ramp, I also took the output of that color ramp into the transmission input of the principled shader. So that basically set how transparent or otherwise the water was, and immediately you can see that's starting to affect it. And how it affects it will depend on the angle at which we are looking. So if I change that angle, you can see we're now getting much more reflections. We are able to see down into the water, which is why you need a plane beneath it in order to show a different color, if you like, further down. And you can change the color of that plane to change the apparent color of the water. So let's just go through those nodes once again. I'll just freeze that render, and we start over on the left hand side. So this is just a texture coordinate node to give our noise a way to be mapped to the surface. I used a scale of 40 there, and a detail of 16, and a distortion of 0.1 to give it a sort of swirls. Then used a color ramp to filter that to make the contrast between high levels and low levels in the noise image more significant. That then got mixed in using dodge in a mix shader with the foam attribute. And we haven't got very much at the moment, and I know why. The foam attribute is generated from here. That's mixed together, and we should also have that at 1. You can see that suddenly there's a lot more of what might be noise. It's a bit crude because the resolution of our simulation is a little bit low at the moment. Turn that up in a moment and re-bake, and then you'll see the difference. But I've turned it down slightly, and that's a little bit better. That then goes through another color ramp, initially to again increase the contrast between the highs and the lows. And we then use that in several places. But first of all, we use it to control the color between white and the sea color, in this case slightly green. And that goes into the base color of our principled shader. It also goes through a multiply node, which is being used to scale it, currently set to 0.05, to control the roughness of the surface. If it's very rough, we won't see through it. It'll just have a specular reflection. The smaller that number, the more shiny the surface will be generally. And it also gets fed down into a bump node, which is used to basically lift the foam slightly above the surface. So you can see it as something that's sitting on the surface rather than just something that changes the color of the surface. We've also got a little bit of subsurface in our principled shader, and I've got that set about 0.36 and this sort of color. You could have other colors, of course, and it's worth experimenting. The output of that shader goes into a mixed shader, on one side of which is the transparent shader, and then controlling it is a layer weight node with the blend set to 0.1, and the control output is the Fresnel output. And then all of that, of course, goes into the material output. So what I'll do now is I'll just bake this ocean to at least a slightly higher resolution so that we can see what's going on slightly better. And I'll also change the coverage. So the coverage here is the amount of foam that's generated. And if I delete the bake, we can also change the speed at which the foam accumulates. So I turned that down, in fact. I set it to 0.25, but I turned the coverage up to 0.1. And you can see that's already increased the amount. So let's put the resolution up to 15, otherwise it will take too long to render, and just bake that. So if we go to rendered view now, you can just about see now that we're getting a lot more foam generated. So you'll need to play around with the settings in here as well as the settings here to get the level of foam that you want. Obviously, if you have too much, it looks unrealistic. If you have too little, then you're losing some detail that you might otherwise have. And bear in mind that all of this foam will be appearing and disappearing quite quickly. So if you have too much of it, it can look a little odd. So I'm just going to delete that bake again and just go back to material view, and you can already see it's slowed down quite a bit because of the increased resolution. We're at 15 now. So I'm going to go back to 10 for a little while, because there's one other thing I want to show you that I didn't put into the final render, and I'll explain why. But it occurred to me that an object floating in water ought to create its own little ripples in the surface, even in a surface that's already rippling and moving quite a bit. So I added another modifier to the ocean. I'll just turn that on. The modifier that I added was the wave modifier. I'll just minimize the ocean. The settings that I used was to have a start position, which was the float object, which we can't see, but we know it's underneath the bottle. I left the speed at about default. I set the height to 0.1, so quite low. The narrowness to 3 meters and the width to 2.2 meters. That just happened to be what worked for me at the scale that I was working. So if I press play, it's quite difficult to see in the material view, but the idea was that this created ripples that flow out. You may just be able to make them out. Little ripples that flowed out from the bottle itself. If I increase the height, perhaps they'll become more visible. So you can just about see them now. They're obviously ridiculously high now. I also put a fall off of 10. Which meant they didn't go on forever. So you should just be able to see there's ripples now rippling out from around the bottle, which was great, but there's one slight catch. Because of the way the bottle is floating on this surface, each of those little ripples that is being created also affects the height of the bottle, which is obviously not quite right. And because of that, the height and the angle of the bottle, because of that, you can see the motion of the bottle becomes much less stable. If I select the bottle and just home in on that. So you can see it's still got all the floating motion that it had before, but it's now got more wobbles and sudden glitchy movements to it. So overall, I was unable to easily remove that. The only way I could think of to completely remove it would actually be to have two identical ocean simulations. One on which the bottle actually floated, and then a second one where I had an object moving along in the same place as the bottle, possibly the bottle itself, but not affecting the bottle's movement, but having the ripples generated there. But that would then be two identical ocean simulations, and I decided that was a bit too much just to be able to add the ripples. But depending on the object you're adding, how big it is, how big your float object is, potentially this can work. I did play around with different size of float objects, and generally speaking, I found, if I make my float object visible again, I found You needed a float object that was a reasonable size in order to get reasonably good motion on whatever object you're trying to float. If you made it too small, the motion became much more abrupt, much less smooth. So I hope you found that interesting. If you did, let me know, and I'll see you in the next tutorial. Thanks a lot. So I hope you found that interesting. If you did, let me know. If you enjoy these tutorials, don't forget to click like and subscribe. I also have a Facebook page and a Twitter account, and I now have a Patreon page as well, and I'll provide links to all of those in the description below. So I'll see you in the next tutorial. Thanks a lot.